Good morning, children. Now, today in science, we are going to start with a new chapter, and the name of the chapter is Solids, Liquids, and Gases. Now, children, when you look around, you will see so many objects around you, so many things around you. Say, for example, pencils, books, tables, chairs, houses, refrigerator, television, cars, isn't it? Washing machine, which are all non-living objects. And besides these non-living objects, you will also say the living objects like animals, birds, insects, butterflies, then including the human beings, right? So whether these objects are living or non-living, all these objects which you can see around you, they are called matter. Okay, so what is matter then? Anything that occupies space and has mass is called matter. So let's take the example of a book only. Now, if you want to keep a book on the table, then that book needed a space, right? So once you keep the book on the table, then you can find that the book, then you can see the book will occupy some space on the table, which means that the book is occupying space and it has also mass. So which means book is a matter. So that means anything that occupies space and has a mass is a matter. Like even you are also an excellent example of matter, living matter, because you also need a space, right? You also occupy space and you have also mass. So which means that matter is anything that occupies space and has mass. Now children, when you look around, when you see all these objects around you, do they look same? Do they have same sizes and shapes? No. They all are totally different from each other. All the objects which you can see around you, they are different in shapes, different in sizes. Like some of the objects will be hard, rigid, having shapes and sizes. And some of the objects, like let's take the example of water, milk, petrol, diesel, oil, they do not have any shape, but they can flow. And some of the objects we cannot see also, like the gases, oxygen, without which we cannot survive, but they are also an object, but we don't see them, we can only feel them. So these are the different objects around you having different shapes and sizes. So why is that? Why do they have different shapes and sizes? Now, I just want to put one example, like take the example of a chair. Now, if I ask you the question like, what is the chair made up of? Then the answer will be, the chair is made up of wood. But when I ask you, what is that wood made up of? Then what will be the answer? Well, the answer is that wood is made up of the smallest particles called molecules. Okay? So all the matter, they are made up of the smallest particles called molecules. Now, in case of the living organism, like in our case, our body is also made up of the smallest particles called cells. So why the matters are different from each other in shapes and sizes? It is because the different arrangement of these molecules. So due to the different arrangement of these molecules in each objects, so each object or each matter, they have different shapes and sizes. They have different properties. So based on these arrangement of molecules in the matter is divided into three groups, or matter has three states, and they are solids, liquid, and gases. Some of the matter you find in the solid state, some of the matter you find in liquid state, and some of the matter you find in the gaseous state. So now we are going to discuss the arrangement of molecules in solids, liquids and gases. So let's see the arrangement of molecules in solids. Now before that, you must learn the two terms. Okay, before you learn the arrangement of molecules, you must learn the two terms, and that is intermolecular force of attraction. One is intermolecular force of attraction, and the second term is intermolecular space. Now what is intermolecular force of attraction? Now intermolecular force of attraction is the force of attraction between the molecules. Because of that force, the molecules held to each other. That is intermolecular force of attraction. And the second one, intermolecular space, is the space between the molecules are called intermolecular space. Alright, so the molecules in solid, liquid and gases are arranged. They are based on actually these two terms, intermolecular force of attraction and intermolecular space. So let's see the arrangement of molecules in solids. I have already drawn that part. So let's see, suppose these are the molecules. So how are they arranged in solids? The molecules are tightly packed. They are closely packed, and what is not there, they do not have any space between them. Which means intermolecular space between the molecules in solids is zero. The intermolecular space is absent. They are tightly packed, closely packed. So which means the intermolecular force of attraction is the strongest. Alright? So in solids, the molecules, they have the strongest intermolecular force of attraction, and because of this, they do not have intermolecular space. And because of this arrangement of molecules in solids, the molecules, they can hardly move. They remain in fixed position. And because of this type of arrangement of molecules in solids, solids have a definite shape and definite volume. So just take the example of some solids, like take the example of pencil only, which you are very familiar with right now, isn't it? So if you think of the pencil, then you can easily imagine the shape of the pencil. You can easily imagine the shape of the books. You can easily imagine the shape of the duster, because they all are solids and the molecules are arranged closely. So because of this fixed position of molecules in solids have definite shape and definite volume. So all the objects which you can see around you having definite shape and definite volume, they all are solid. Okay? Now the next one is liquid. So how are the molecules arranged in liquids? Now in liquids, the intermolecular force of attraction is weaker than that of the solid. So once the intermolecular force of attraction is weak, then the molecules, they have intermolecular space. Means there is a space between the molecules of solids. Is that clear? So that means how are the molecules arranged in liquid? Now the molecules are loosely packed. Loosely packed means there is a space between the molecules of solids. Alright, so due to this type of arrangement of molecules in liquids, the molecules, they can move. They can move around in all the directions. And because of this movement of the molecules of liquids, the liquids, they do not have fixed shape. They can flow. Is that clear? They can flow. So they do not have a fixed shape. They can take the shape of any container. Is that clear? But these molecules, while moving around in all the directions, they will not leave their group. And because of that, the volume is fixed. So let me show you one activity actually. Suppose I have one glass, a bottle out here, and this bottle, it has water here. Now you know water, it is the most common example of a liquid, right? So this water, they can flow. So the molecules in this water, they are arranged loosely arranged. Because of that, they can move. Molecules can move, means this water can flow. So the water which is here inside the bottle, this water, it has taken the shape of this bottle. Now when I pour this water in the glass, then the water will take the shape of the glass. So let's see. Now you can see that. See, the same water which is in the bottle has taken the shape of the glass, which means water, they do not have a fixed shape. But the volume is same. Like whatever the amount of water in the bottle, I pour it in the glass, the volume is same. So that's why the liquids, they have a fixed volume, but they do not have a fixed shape. Right? Then the next one is gases. Now in gases, the intermolecular force of attraction is the weakest. So when the intermolecular force of attraction is the weakest compared to solids and liquids, then the intermolecular space between the molecule of gases is the largest. So they are far apart from each other. The intermolecular space is the largest. So because of this largest intermolecular space, the molecules in gases, they can move randomly in all the directions. Okay, so these gases, they will fill the entire container. But if the mouth of the container is not closed, then the gases can easily escape. Which means gases, they do not have a fixed shape also, and they do not have a fixed volume. Is that clear? So these are the three different states of matter. Alright, so if you see the differences between these three states of matter, then solid, they have a fixed shape and fixed volume, and they do not flow. And liquids, they have a fixed volume, but they do not have a fixed shape, and they can flow. Then in gases, neither have a fixed shape, nor do they have a fixed volume. Alright, so this is all about the three different states of matter. Now comes solution. Now what do you mean by the word solution? Now before you learn the term solution, you must learn the two terms first, and that is, one is solute, the other one is solvent, and the third word is solution. Is that clear? So what is solute? Now solute are basically, they are the substances, matter only, they are substances which can easily get dissolved in another substance. Like let's take the example of sugar, the most common example. Isn't it? So sugar, when you add sugar in water, then usually what happens to the sugar? They can easily get dissolved in water. Again, take the example of salt. When you add salt in the water, salt can easily get dissolved in water. So that the substance which can get dissolved in another substance, that substance is called solute. So here, example of solute is sugar. Sugar can easily get dissolved. Okay? Then what is solvent? Solvent is usually in the liquid form, and solvent are those substances which can dissolve other substances. Like let's take the most common example of water. Right? Water is a solvent. Why? Because water can dissolve many substances. So water is also called a universal solvent. So suppose when you add sugar in water, then water can easily dissolve sugar. So what is water then? Water is a solvent. So when this solute and solvent, when they mix up, then they will form a solution. So what is solution then? Solution, it is a mixture of solute and solvent. So example, when you add sugar and water, or when you mix sugar and water, sugar can easily get dissolved in water, where sugar is solute and water is solvent. And when they mix, they will make sugar solution. What type of solution? it is sugar solution. Since the solute is sugar means the solution they will make, the mixture they will make is a sugar solution. You can take the example of salt also. Like when you add salt and water also, when you mix, they will also make a solution, and that solution is salt solution. You can do this experiment at home just to know more clearly about solute, solvent and solution. Try, keep 1 spoonful or 2 spoonfuls of sugar in a cup, and that is solute, water in a glass, solvent, mix it, and the mixture that you will find is solution. Try this activity at home. It's fun, right? Then, now if you see, now the substances that will get dissolved in the liquid, there are 2 types of substances. Alright, one is soluble. Now see the term, soluble, and the other one is insoluble. There are 2 types of substances. One is soluble substances, another is insoluble. Now soluble substances are those substances which can easily get dissolved in any liquid or other substances. Example, which are the soluble substances? Sugar, salt, they can easily get dissolved. Like you can take the example of milk also. Milk and water can easily mix. So those substances which can easily get dissolved in another liquid, that type of substances are called soluble substances. So insoluble substances are just the opposite of soluble. Means those substances which cannot dissolve in other liquids, any liquids, they are called insoluble substances. So try to dissolve sand in water. Add sand in the water. Do you think sand will get dissolved in water? No. So sand is an example of insoluble substances. Okay, children? So today I am going to do this much now. In our next class, we will discuss the separation of liquids from solids. Thank you, children.